Hello everyone, I am Abhishek Paudel. Today I am going to do a numerical which is from chapter number 4, hydraulics. This numerical is from establishment of flow in unsteady flow in pipe. In our past lectures we have been dealing with the problem which are from sudden closure of valve, but this is a type of problem which is suddenly opening condition of a valve. So we deal with this is a different type of problem. A pipe is already in valve closed condition, and when the valve is suddenly opened, and what will happen, what time it takes to time required to reach 95% of steady state discharge. Okay, it takes some time to reach the steady state discharge, but question is asking you to estimate the time required to reach 95% of steady state discharge. Okay, so how to do this type of problem? Okay, let's go through the problem. Of 15 centimeter diameter, 1500 meter long pipes lead from a large reservoir. Okay, the question is from like this. This is a reservoir, and the pipe leads from a reservoir, and it has a valve. Okay, at the downstream end, it has a valve. It has a valve at the downstream end. So it is already in the closed condition. Okay, valve closed condition. It is already in the valve closed condition. There is water, and this is already in the valve closed condition, having some head. Okay, question tells you of 15 centimeter diameter, 1500 meter long. I have written here diameter 0.15 meter and length 1500 meter, and head. How much is the head? 20 meter. Outlet is 20 meter below the water level in the reservoir. This here's outlet. This is outlet is 20 meter below. Here is 20 meter. Okay. 20 meter. Outlet is 20 meter below the level in the reservoir. Okay. And now, if the valve at the outlet pipe is suddenly opened, if this valve is opened suddenly, then estimate the time required to reach 95% of steady state discharge. This means at some time it will be at a steady state. The discharge will be in steady state. The velocity will be in steady state. So it asks you to find out the time required to reach 95%, not 100%, 95% of steady state discharge. Okay. So for this, it has given you friction factor F and a minor loss coefficient, that is 5. Okay. This is a minor loss coefficient K1, that is 5. The question has given you this data. So now let's find out the major loss coefficient and minor loss coefficient. Major loss coefficient, which is called Kf. Kf is equal to F L by D. Okay, F L B square by 2G D. You can exclude this B square by 2G just like this, B square by 2G here, excluding B square by 2G. This is minor loss coefficient, and just like this is the major loss coefficient. Here F L B square by 2G D. Okay, so let's put the value here. How much is F? F is equal to 0.02. So 0.02 into L, how much is L? 1500, and divide by D, how much is D? 0.15. You will get how much? 200. Okay, this is a major loss coefficient. And let's calculate the minor loss coefficient. This is called K1. Here minor loss coefficient is K1 B square by 2G. So K1 is already given here 5. So I write 5 here. K1 5. Total loss coefficient. We must need this total loss coefficient. Total loss coefficient is equal to, that is termed as K, that is equal to 200 plus 5, that is equal to 205. Okay, this is a total loss coefficient in this system of pipe. Okay. Okay, now let's go to the to find out the time required to reach 95% of steady state discharge. Okay, for this I am going to erase this. Okay, to find out time required to reach steady state discharge, we must find steady velocity. Okay, for steady flow, if there is some loss coefficient, then you can write V naught is equal to under root of 2GH In normal condition, V naught is equal to under root 2 GH. But if there is a loss, then you must write 1 plus K here. Okay. We have already found out K, that is 205. Total loss coefficient, that is 205. Let's substitute here H. We have got H how much? 20 meter. Head is 20 meter. So let's substitute here under root 2 into 9.81 into 20 divided by 1 plus K is how much K? 205. Then you are going to get the value 1.38 meter per second. You are going to get 1.38 meter per second. Steady state velocity, that is 1.38 meter per second, considering the total loss coefficient. Okay. So now let's go to find out the final time required to reach 95% of steady state discharge. Okay. We have found out steady state velocity, that is 1.38 meter per second. 1.38 meter per second. I write here V naught is equal to 1.38 meter per second. Okay, meter per second. So this is steady state velocity. So now let's find V by V naught is equal to Q by Q naught. I can write like this: V by V naught, Q by Q naught, because same area in both case. This V, Q are particular velocity, particular discharge, and V naught, Q naught are the steady state discharge and steady state velocity. Okay. So you can write this. Directly. So now let's write the formula of establishment time. For establishment of flow, time required to reach 95% of steady state discharge. 95% of steady state discharge. Okay. So let's find out the time required to reach the 95% of steady state discharge. That is, we write the formula here: T is equal to L by 1 plus K V naught. You have to remember this formula. Okay. V naught Ln 1 plus V by V naught 1 minus V by V naught. 1 plus V by V naught divided by 1 minus V by V naught. L by 1 plus K V naught, Ln 1 plus V by V naught 1 minus V by V naught. This is the time required to reach the 95%, or how much percentage? The question gives you the percentage. The percentage may be 100%. So 95% time required to reach the 95% of steady state discharge. Okay. So for this, we have to substitute values here. So let's substitute values here. Substituting the value, how much is L? L is equal to 1500 meter. L is equal to how much? 1500 meter. 1500 meter divided by 1 plus K. K is how much? We have found out K, 205. 1 plus 205, and V naught is equal to 1.3. How much is V naught? V naught is 1.38. Okay. 1.38. And now Ln 1 plus V by V naught, and how much is the V by V naught? Okay. So V by V naught is equal to Q by Q naught. Q by Q naught means how much percentage? 95%. So you can write 0.95 here. Okay. You can write V by V naught is equal to Q by Q naught is equal to 95%. That means 0.95. You can substitute the 0.95 over here. 1 plus 0.95 divided by 1 minus 0.95. Okay. You have substituted all the data is here. You have found out K, that is total loss coefficient, that is 205. You substitute here, and you have found out the V naught. V naught is how much? 1.38 meter per second. 1.38 meter per second. If you substitute this here, and we have found out V by V naught, that is a percentage to reach 95% of steady state discharge. This is a steady state discharge. So 95% means 0.95. That is, if you put here, then you are going to get a time in seconds. Okay. How much? 19.33 seconds. You are going to get 19.33 second time required to reach the 95% of steady state discharge. Okay. So this is how the problem is done. Very easy, but you have to remember the formula in this case, and you have to consider the major as well as minor. If the question gives you minor coefficient, but the question may ask you by only considering the major loss coefficient. Okay, this question can also be done by considering only the major loss coefficient. So let's do that one also. Repeat the question, neglecting minor loss coefficient, minor loss. Okay, if the question asks you to neglect the minor loss, then what you have to do? Okay, so let's repeat this. K of, this is E of L by D, if you put 0.02, L is equal to 1500 and D is equal to 0.15, you are going to get 200. And here K1 is neglected, here, K1 is 0. Okay, minor loss coefficient K1 is 0, I have neglected here. So total loss coefficient how much? Total loss coefficient is equal to K is equal to K1, K of plus K1. K of is 200, K1 is 0. So that's why K is equal to 200, only 200. For steady flow, steady state velocity V naught is equal to under root 2 GH by how much? 1 plus K. Under root 2 into 9.81 into H is how much? H is 20 divided by 1 plus K is how much? 200. Then you can get the value of V naught 1.397 meter per second. 1.397 meter per second. Okay, we have found out the steady state velocity, neglecting the minor loss. So now let's find out the time required to reach 95% of steady state discharge. Time required to reach 95% of steady state discharge. Steady state discharge. So let's write the formula again. T is equal to L by 1 plus K V naught, Ln 1 plus V by V naught divided by 1 minus V by V naught. Okay, we have found out V naught here. V naught is how much? 1.397. So let's put here K is 50, L is 1500 divided by 1 plus K. K before how much was K before? 205. Now it's 200. We have neglected the minor loss coefficient. Okay, so into 1.397 is equal to Ln 1 plus 0.95 divided by 1 minus 0.95. That is, you get the value is 19.57 second. Okay, this is the time required to 19.57 second. This is the time required to reach the 95% of steady state flow, steady state discharge. So neglecting the minor loss in this case. Okay, so this is the question is like this. Okay, thank you so much. We will see in the next video. Study well. Okay.